Hello everyone. Today we will be solving educational round 168D, maximize the root, where you are given a rooted tree at 1 and a value a of I at each vertex. You can perform the following operations any number of times. You need to choose a vertex V which has at least one child, then increase the value of that vertex by 1, and then you need to decrease the value of each of its subtree vertices by 1. Okay, and you want that after each operation all the values on vertices should be non-negative. Your task is to calculate the maximum possible value at the first vertex. So first of all, I'll show you how this question works by the first test case. So in the first test case we have some kind of tree, 1, 2, 3 and 4, and the values are 0, 1, 0, 2. So first we can perform our operation on vertex 3. If we perform one operation on vertex 3, then this 0 becomes 1 and this value 2 becomes 1. Now if we perform the operation on vertex 1, then the value of this vertex becomes 1 and value of all other vertexes turn to 0, and hence 1 is our maximum possible value found at our root vertex. So, as you might have noticed, if we are performing an operation at a particular vertex, each of its entire subtree, all of those values are decreasing. So, the best strategy here is to, like, I'll draw a tree. Let's say you have some kind of tree like this. So, if you are performing an operation at vertex 1, what you need is the values of each of the remaining vertices. The minimum of all those values should be as maximum as possible, because let's say the minimum out of all of the rest of vertices is x, then the maximum operations I can perform on one is x, because I cannot let this x go non-negative. So basically our main goal now is to increase the minimum value of a of I in all the remaining nodes as much as possible. Okay, so let's have this this strategy for this. Let's say we have value over here at as 8 and value at the child as 12, which means that, let's say that if we are comparing all the vertices from the subtree of 2, the minimum we are getting is 12 and the value of 2 is 8. So what we can do to increase the min? We can perform two operations. So our minimum increases to 10. Okay. Now let's say we have an even number and one odd number. Okay. Over here also we need to increase the minimum value as much as possible. I will again use the mean of both values, which would be 9. So I will add 2 over here, subtract 2 from here. So now our operation is that we need to find the minimum value of all a of I from the subtree of this particular vertex. Okay, so now I'll show you how to do it on the last test case. The last test case looks like 1, 3, 2, 5 and 4. Okay, and our values are 2, 2, 5, 3, 9, 6. Okay, so first we will perform our operation on vertex 5. Okay, our current value is 6, and from our entire subtree the minimum value we can get is 9. So now we change the value to the mean, which turns out to be 7. So increase this by 1, decrease this by 1. The value of 5 becomes 7. Now we are on vertex 2. When we are on vertex 2, our value is 5, and out of entire subtree of 2, the minimum we are getting is 7. Again, we take mean. 5 plus 7 upon 2 turns out to be 6. Increase 2 by 1, decrease 5 by 1, decrease 4 by 2. So now after this, the value of 2 becomes 6. Okay. Now we are on vertex 3. The value of vertex 3 is 3, and our minimum from all of our subtrees is 6. Again we take mean. 3 plus 6 upon 2, we get the value of 4. Increase this by 1, decrease by 1, we get 4. Now when we reach the root vertex, what we need to do is we will directly add the minimum of its entire subtree. Okay, so the answer is 2 plus 4, which is 6. Now let's say that you have a case like this. You have a parent whose value is 8, and you have a child whose value is 6. Now if you perform any operation on the parent over here, then the minimum would always decrease. So performing an operation over here makes no sense. So the only thing we will do is we will swap these both values. Why we would do this? Now let's say that we have some sub children. So if I want to find the minimum of an entire subtree, I want that the minimum would be out of these values. Now if the values were swapped, like this was 6 and this was 8, then it is confirmed that on my child nodes I will get the minimum of entire subtree. But what if the value of parent is 8 and the value of children is 6? Then you would need to check the children of children to get the minimum value, which is 6. But I don't want to check that deep because that might go till n square. So what I will do is I will just swap these two values. So now I guarantee know that the minimum of my subtree will lie in the childs of my current parent. Okay, I'll show you this in one example. Let's say we have 1, 2, 3, 4 and 5. Let's say the values of 5 is 6, 4 is 6 and 3 is 8 and 2 is 10. Okay, now if we are performing operation on vertex 3, it is of no use because the minimum value of the subtree will only decrease. But I want that for vertex 1, when I am finding the minimum value of the subtree, I want 6 to come. So I will just swap these two values. This becomes 6 and this becomes 8. So after that, I will always find the minimum of entire subtree in the children of the vertex, the exact children. I don't need to iterate the whole tree below it. Okay. Now I will attach a C++ submission in 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 the comments. Okay. For now, this is Java code, but it is easy. I will explain. Okay. This is our DFS. Okay. We are calculating the minimum of our child nodes. Okay. I have first initialized minimum to infinity. Then if my minimum is not if my minimum is not infinity, that means I have at least one child node below. So now I want to perform my operation. If my current value is greater, which means I need to swap the values. So I am taking the minimum into A of source. Okay. And now else, if it is less, then I need to perform my operation as before. I took the minimum of my current source and the minimum. This minimum contains the minimum of the entire subtree of that current parent. Okay. So this is how you will perform the operations on every node. Just when you are on the first node, you just have to add a minimum to A of source, and that will be your final answer. At the end, you need to print A of 1, and that should be good for you. Okay. I will attach C++ submission in the comments. So if you want C++, make sure to check that out. Okay. So thank you guys for watching. Make sure to like, share and subscribe the video to never miss another tutorial.